Here in problem number 115, we're trying to identify which of the graphs is f, which is f prime, which is f double prime. And we're not given the labels, we're just given the shapes, and we're supposed to use our understanding of the connections here between the three to figure out which ones they are. One thing to remember is that when a function is above the x-axis, its value is greater than 0, and when a function is below the x-axis, its value is less than 0. So we know that, but we want to make sure we keep that in mind. Another thing to keep in mind is that when a function, let's say f, when f is increasing, it means that everywhere along the way, when you draw a tangent line or we calculate the slope of the curve, anywhere along the way that the function is increasing, its rate of change or its slope is greater than 0. So if f is increasing, f prime is positive. If f is flat, f prime is equal to 0. And if f is decreasing, then f prime is less than 0, is negative. And likewise, if you go from f prime to f double prime, whereas f double prime is the slope of f prime, then we know that if f prime is increasing, then f double prime is positive. If f prime is flat, f double prime is equal to 0, and if f prime is decreasing, then f double prime is less than 0. So we can easily go from one to the other if we understand this concept here. I've got a fly, I got to kill it, hold on. So I don't know if you saw that fly buzzing around, but anyway, it's gone now. Back to this, there's a couple different ways you can look at this problem and analyze and come up with a solution. So number one, you can just guess and check. So pick one of these functions. I'll just pick this one here, and I'm going to say, okay, is this f? Can this be f? Well, what is happening here when x is negative? Well, f is decreasing. So f is decreasing, slope is negative. That means that its derivative would be negative. Well, that means the derivative graph would have to be under the x-axis until we get to there. So we see, oh, this graph right here, this line right here is under the x-axis, which means that this line's value, the value of this function here is negative. Okay, so the value is negative here, and then that would coincide with the derivative or the slope of this. The derivative here is negative, this value is negative, so this might be the derivative graph. And then what do we do here? When we see this flat spot, on the flat spot here on this curve here that we're thinking, well, this might be f, this flat spot here, that would have to coincide with the value of the derivative being equal to 0. Well, that also meets the straight line also meets that criteria. And then over here, where the slope is positive, anywhere along the curve here, the slope is positive, which means the derivative would have to be positive. That would mean that the derivative graph would have to be above the x-axis. And that's indeed what this is. So then this would be, oh, this would coincide with everything we need it to be. So if this is f, then certainly this graph here would be f prime. It can't be this other graph here. This curve here that looks like a third-degree polynomial, this curve here, no way can it be f prime if this graph here, the parabola, if the parabola is f, there's no way that this graph here can be f prime. Why? Because to the right of 0, f prime is, if this is f, then f prime, the slope here would have to be positive. Well, the slope right here, if this is the derivative of f, and if this is f and this is the derivative, this would show the value of this function being negative. Here, the value being negative, and we can't have the derivative of this function here being negative right there. So it can't be that because of what we just talked about. So it narrows it down to this one. Now, then if this is f prime, if this straight line is f prime, then bottom line, first of all, we know that the straight line is definitely the derivative of the parabola. So the parabola has to go right before the straight line. And the straight line, if this other curve is f double prime, then we're good. So let's check it out. So f prime, notice that everywhere along the way we can see a positive slope everywhere. So if f prime is increasing, right here, if f prime is increasing, that means that its derivative would always have to be greater than 0. Since this straight line here is always increasing, then that would mean that its derivative, and then we only have one other graph, would be this one here. Its derivative would have to be always greater than 0, which means that this graph would have to be always above the x-axis. and it's not. We can clearly see it's not. So therefore, this function can't be f, but we know that the straight line is the derivative of this one. It's not the other way around. You can check it for yourself. So that would mean that this function has to be the derivative of this one, which means it always has to follow that, which means the only other one that could be f, this one cannot be f because it doesn't have a derivative graph here. So this one would have to be f of x. And this, let's check it out. So if this graph is f of x, then it would have to be this one being f prime of x, and then this one being f double prime. So that's the one I'm going to stick with, and that's this one right here. This graph is f double prime, the parabola is f prime, and the what's again looks to be a third degree polynomial cubic, it looks like this is f of x, and it has to be that. So let's just confirm. If this is f of x, let's check it out. Then over here, anywhere along the way here, until we get to that spot right there, at x equals 0, the function is increasing. So if it's increasing, do we have a graph that, does this graph over here meet the criteria? Is it greater than 0? Yes. F prime then is greater than 0. When x is less than 0, f prime is greater than 0. And then when f of x is flat, is f prime equal to 0? Yes, the parabola does meet that. And then again, to the right, everywhere along the way, the curve is positive, has a positive slope. And therefore, it's increasing. So it's increasing again. So increasing again, is the graph of f prime greater than 0? Yes, the graph of f prime is above the x-axis. And so therefore, this is your f of x, this is your f prime, and this is your f double prime. And we already went through the fact that the straight line is the derivative of the curve here, the parabola. And now we've shown that the parabola is the derivative of this cubic function. And you might have already picked up on this along the way, but that's kind of the long way to do it, and sometimes you have to do it that way. But when all three functions are polynomial functions, you can get away with, look, you've got the cubic function, so you have y equals x cubed. Let's say it's x cubed minus 1. And then the derivative of x cubed minus 1 would be 3x squared. And then the derivative of 3x squared would be 6x. So you can do it that way, but I don't want you to rely on that, because that can only get you the answers when the functions are well known and easy to spot. Like, again, that's a cubic, second degree, and then first degree. So the degree always drops by 1. If you notice, when you take a derivative of a polynomial function, the degree drops by 1. Degree drops by 1, minus 1. And then again, the degree drops by 1. So again, that's the way you can look at it as well. So that's just another way to check.